Alright, welcome back. So we are continuing with our free response questions again. This time, objective is to estimate displacement, distance, speed, velocity, acceleration, magnitude of acceleration using graphs of piecewise functions for the velocity of an object. So we have a graph today for the first 12 minutes of a bicycle ride. So Karen's riding her bicycle along a straight road from home to school, starting at home at t equals 0 minutes and arriving at school at 12 minutes later. During the interval from 0 to 12, her velocity in miles per minute is modeled using this piecewise linear function above. I want you to find the acceleration of the bicycle at 7.5 minutes and indicate the units of measure. What do I have to do?
So acceleration at 7.5 is the slope of the its change in velocity change over time.
Okay.
So it's just acceleration.
Okay, so how can I set it up?
So f prime v8 minus v7 over 8 minus 7.
Okay. So I could say our acceleration at 7.5 is equal to v prime at 7.5, which is exactly what you said. My change in the velocity from 7 to 8.
So that's gonna be bottom part is 1 and 0.2 minus 0.3.
Okay. So that's 0.2 minus 0.3 over 1. So what's our answer?
Minus 0.1.
Okay, and units?
Meter per second square.
Not for this one.
Wait. Meter per minute square. No, miles per minute square.
Miles per minute squared. Okay. And then I want you to explain the meaning of the integral from 0 to 12 of the absolute value of the velocity in terms of a trip. And then find the value.
So that's the total distance. Total distance that Karen rides her bicycle along the road from home to school. From t equals 0 to t equals 12.
Okay, I like it. So that was the integral from 0 to 12 of the absolute value of her velocity in terms of time. You told me it was the total distance that Karen traveled. Okay, and then I need to figure out what that total distance is.
So you have to flip the negative section to positive section. So
Okay.
it's gonna be, and then but the area, the triangles are the same. So 2 times 0.2 divided by 2 is 0.2 but there are two of them, so it's gonna be 0.4 and 0.4, and then 1 times 0.3 divided by 2 is 0.15.
Okay, so we have the two triangles, and then what?
0.3 times 1 divided by 2.
Okay,
Then 1 times 0.3 divided by 2. No, just 1 times 0.3.
okay,
And it's trapezoid.
okay, trapezoid, that's at 0.3 and 0.2.
Mm-hmm.
So, what's the equation?
Wait, can I see the numbers? You have to add the longer section. So it's 0.3 plus 0.2. It's 0.5 times 1 divided by 2.
Okay. 1 times 0.3 plus
Point.
0.2 divided by 2.
Mm-hmm.
Okay, so trapezoid plus,
Rectangle it's and 1 times 0.2 divided by 2.
okay, so you said 3 times 0.2 plus 1/2 times 1 times
1
0.2.
times 0.2. Mm-hmm.
Okay. So I'm going to do this and add everything together.
Mm-hmm.
Okay. Oh, I think this one messed up when I converted that to an equation. So let me rewrite this one really quick. This was 1/2 times 2 times 0.2. Okay. So let's start adding these together.
Yeah, but I cannot see the numbers.
Okay, is that any better?
Oh, I think it stopped. Wait. Can you scroll down?
I'm going to send the picture in the WeChat and Skype chat.
Uh-huh. Oh, so that's gonna be. We have to do it. Is this without calculator?
Let's see, 2009 and question 1. Okay, you would have a calculator for this. So we can just throw this in the calculator then.
Oh, yeah, I think it's easier to do in brain. So, first one, it's gonna be cancelled out. So it's 0.4 plus 0.4 plus 0.15 plus 0.3 plus 0.25 plus 0.6 plus 0.1. 1.8, I think.
Okay. So then we'll start adding all of these together. Okay, you're good. What are our
Oh,
units?
it worked. Miles.
Awesome. What would this have represented if we didn't take the absolute value?
Just to distance.
Not distance?
That total distance.
We did take the absolute value, and so this represents total distance. But if we did not take the absolute value, what would this represent?
Total displacement.
Displacement. Okay.
Yeah.
Right. Shortly after leaving home, Karen realized she left her calculus homework at home, so she returns to get it. At what time did she turn around to go back home, and why? How do you know?
Wait, can you send the picture? Oh, wait. Shortly after leaving home. Oh, so when she turned around, it means that her velocity is 0. So it's gonna be at time 2.
Okay. So Karen returns home at time t equals 2. As what's your reason?
Because at t equals 2, her velocity is 0, which means she turned around.
Just having a velocity of 0 doesn't mean she turned around. So we need a little bit more information.
Her velocity changes from positive to negative.
There we go. And changes from positive to negative. Okay. Then last one. We have another person who rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by this other function, Wt, where Wt is in miles per minute for 0 to 12 minutes. I want to know who lives closer to the school, Karen or Larry, and then show the work that leads to the answer. So what am I looking for when I'm looking for who lives closer to the school?
Oh wait, it stopped the game.
Okay, so you should have the copy in case the video freezes.
Oh, yeah. Bicycle along. Larry also rides his bicycle along a straight road from. His velocity is this. Who lives closer to school? Who lives closer to school? So, so if we integrate
Okay, so we need to integrate. What will it represent?
both the if we integrate, it represents displacement.
Okay, so we need the displacement for both.
And then we choose the smaller number.
Perfect. So let's do our integral of, we'll do w first. Okay, it also took Larry 12 minutes. So we're going to integrate WT from 0 to 12
Mhm.
in terms of time. We do need to show the work that leads to the answer. So we're going to integrate pi over 15 sine pi over 12t. Pi over 12, right? Yeah. In terms of time. Okay, so what's going to happen when I integrate this?
Integrate PW, right? Because I cannot see it. VT.
So when I integrate pi over 15 sine pi over 12t dt, what will happen?
Pi over 15.
Okay,
Oh, today internet connection is bad.
I'm just trying to integrate WT. So what happens when you integrate WT for a general form?
Wait, so pi
So they would probably take it if we just plugged into a calculator, but they did ask us to show the work, so I'm going to integrate this by hand.
oh,
So what happens when we integrate?
so minus cosine
Okay, what's the coefficient though?
pi square over
Not
180.
Not quite.
Oh wait, it's pi cancels out,
There we go.
so 4 over 5.
Okay, perfect. Negative 4/5 times what?
Cosine, we should have minus in front, and yeah, we leave the, so it's minus 4 over 5 cosine pi over 12t.
Okay, and then we'll need to plug in our upper bound minus lower bound.
So if we plug in 12, it's sine pi, so it's minus 1. Can you call me again?
Yep. Okay, I'm pretty sure that was my end. I've just changed some things around with my network.
Oh, yeah, it's clear to hear right now.
Okay, that was definitely my end then. I apologize. Okay, so we are still estimating WT. Can you see now?
Uh-huh.
Okay, I'm going to plug in upper bound minus lower bound.
So if you plug in 12, it's cosine pi. So it's 4/5. Minus cancels out each.
Okay,
So 4/5 minus 0. Cosine 0 is 1, but there is minus, minus, or plus.
okay. Cosine 0 you said was 1, so this is 4/5 plus 4/5.
Mm-hmm. So 8/5.
Okay, what are my units?
Meter. No, miles.
Okay, and then we're going to do the same thing for our V of t. Now, our V of t, when I integrate without the absolute value, will be equal to everything that we had last time, except all of our negative areas will be negative this time. So I'm just going to copy this and then make that second triangle negative.
Mm-hmm.
Then we can re-add everything. So that's just going to cancel out these first two times,
Mm-hmm.
which will leave us with all of the rest of this part.
Yes.
Okay, so what happens when I add all this together?
0.3, 0.45, 0.7, 1.3, 1.4.
Okay, 1.4 units?
Meter. No, miles.
Miles. Okay, what is 8/5? Just so I can get a comparison.
Mm, 1.6.
1.6 miles. Okay, so then we need to answer the question. Who lives closer to school, Karen or Larry?
Karen.
Okay. Awesome. Any questions on anything we did?
Nope.
Okay, I'm gonna shrink this and then we'll take a look at the scoring guide really quick. Okay, so first part. Estimate the acceleration at 7.5. Okay, we've got answer of negative 0.1 miles per minute squared in units. Okay, so we've got 2 for 2 for there. Then the meaning of the integral is the total distance that she rode in the 12 minutes in miles. Okay, so that was good. And then the value is 1.8 miles. That was good. So 2 there. She turns back at 12 because the velocity changed from positive to negative. Okay, we've got that exactly. And then the distance, 1.6 and 1.4 miles, integral and value. Okay, and then Karen's distance. And conclusion, Karen lives closer to school. Okay, cool. 3 points. So that's 9 out of 9, and we're good.
Yay.
All right. So for the homework, I'm going to have us finish up the second and third free response question from this year.
Mhm.
And we'll keep going next week to do 4, 5, 6. Any questions on anything we did today?
No.
Yeah, that's pretty much perfect. Thank you for dealing with the connection issues pretty well.
Mhm.
So you're pretty prepared today. So I will post this as soon as it finishes uploading, and then I will see you tomorrow for physics.
Bye bye.
Goodbye.